All right, seventh graders, Mr. C coming at you one final time for the year. Really wish that we hadn't been able to end the year this way. I really would have loved to have been in class, but this is what we got to do. So I'm going to just go ahead and get started, try to get this done and through as quick as we can here so you guys can wrap everything up. So at the end of the year, when we finish up with photosynthesis, one of the projects I like to do is called the Skittles Lab. And unfortunately, because of our circumstances, we're not going to be able to do that. But we can still simulate this. And that's exactly what we're going to do with this little lab that I have set up for us. So typically how this works, guys, is you would be working with a partner. I would give you guys Skittles, and you would actually get 3 different color Skittles. Now, for representation, I have some Skittles here. Okay, and the 3 colors that I actually would have chosen to use, because these are my favorite ones, really large, got purple, red, and orange. And how the Skittles Lab works is each color represents a different element that's part of the photosynthetic and cellular respiration processes. So basically what you would do is you would take 72 Skittles, you would build the molecules from those Skittles and then arrange them to follow the photosynthesis and cellular respiration formulas. Since we can't do that, we're going to have to use the next best thing, and that's going to be colors. Okay, so real quickly, refresher for those of you that maybe had missed it last time. We've already talked about the photosynthesis equation. Okay, and one thing I want to make sure that I address with you guys here, especially when I talk about the light energy, we know that it comes from the sun. Okay, so 6 carbon dioxide molecules, 6 water molecules, light energy from the sun makes a glucose, C6H12O6, and 6 oxygen molecules. Okay, cellular respiration formula is almost identical, just flipped. Okay, it's very, very close. But here is the biggest difference. Okay, we actually start with that glucose, we add the oxygen, we then use ATP energy. And guys, we get ATP energy from the food that we eat. So all the food that you guys eat throughout the day, that's going to be converted to ATP, which then can be used in this process. And what we give off is the carbon dioxide molecules and the hydrogen molecules. Now, one of the things we got to understand about chemistry is that elements that combine, carbon dioxide, CO2 for example, it's called a compound, and it's actually held together by bonds. And what we're going to do to represent bonds is we're just going to use simple lines. And there's 2 different types of bonds that we're going to be using, and I'll model them here in just a second. But here's what we're talking about, guys. A very weak bond when it comes to chemistry is going to be represented just simply by a single line. Okay, a strong bond is going to be represented with a double line. So in the case of photosynthesis, and I'm going to kind of walk through each and every step of it here, but in the case of photosynthesis, when we talk about carbon dioxide has a really, really strong bond. So when I'm going to, or if I were building those molecules with my Skittles, I would actually represent them with a very strong bond. So carbon dioxide is 1 carbon attached to 2 oxygens. Now, for my particular choosing here, and I'm not going to go much farther than this, you can see that I'm going to use these different colors. I'm going to use orange to represent carbon, red for hydrogen, 18 for oxygen. And what I'm trying to show you here is that the first number that I wrote here, that's going to be the number of those atoms of that element on the reactant side of the process, the number on the product side. Notice that the numbers are the same. That's because we can't create or destroy anything in a chemical equation. That's the law of conservation of matter. So for instance, guys, if I was going to draw a carbon dioxide molecule, carbon 1, oxygen 2. In this case, I would have to have 2 oxygens. And those oxygens are going to be on either side. I know they're not the same size. Bear with me, I'm not an artist here. Okay, they're going to be on the same, or on opposite side, excuse me, of the carbon. So the carbon's going to be found right at the middle. And you just heard me say that carbon dioxide has a very, very strong bond to it. So that means that there are 2 of these bonds attaching that 1 carbon to the oxygens that are here. Okay, that is 1 molecule of carbon dioxide. So if we were to represent photosynthesis in which there are 6 of them we'd have to draw 6 of those bad boys. Okay, that's only carbon dioxide. Let's go to the next part of this. Let's go to water, H2O, good old aqua. All right, so H2O means that there's got to be 2 hydrogens attached to 1 oxygen. Okay, now this one's a little different. Water actually has a really, really weak bond to it. So at the very center, because there's only 1 of those oxygens, that's where I'm going to go ahead and I'm going to put that oxygen. It's going to be kind of at the center. But what we do know about water, guys, is that it has a different shape than carbon dioxide. It's not going to be like a barbell, like a straight across line like we just had. We actually are going to put, and you'll notice that I'm using red here for my hydrogens because that's the color that I chose. We see that they're kind of actually at about a 45-degree angle up from that oxygen that's there. Now, you heard me say that water has a very weak bond. There's only 1 line connecting it. That is a very model representation of what water looks like. And again, when we do photosynthesis, we actually would have to go ahead and draw 6 of those to represent that, okay? Light energy. When it comes to the light energy part of photosynthesis, where do we get light from? The sun, maybe? Maybe it's light bulbs, okay? That's actually what we'd have used if we'd been growing plants, which we didn't get a chance to do either, but it's okay. You guys probably know how plants work. Anyway, guys, when we get to the light energy part of the equation, you would have to draw something that would represent that light energy. So the easiest thing for me is to draw a sun, and I'll show you how I did it in just a bit, but I'm going to go ahead and I'm going to skip forward because I want to get to the other side of the equation, because the next molecule is going to be glucose, and glucose is really, really hard to draw and understand sometimes because it's so big. But what we remember is that in order to make 1 molecule of glucose, we got to have 6 carbons, we got to have 12 hydrogens, and we got to have 6 oxygens. So the one thing I want to make sure that I mention to you guys is carbon has to make up the backbone of that particular element, okay, or excuse me, of that compound, not element, compound. So what I'm going to do to build my glucose would be, if I were using Skittles, I would put all of my carbon Skittles in the middle, flank either side of them with the hydrogens, and then kind of stagger the oxygens off of those. And that's exactly what I'm going to do here. So I'm going to start by drawing 6 carbons. Okay, I'm going to go ahead and move this down a bit so you guys can see what I'm doing. All right, the hydrogens then, of which there are 12 of them, they have to be on either side of this thing. So I'm going to go ahead and I'm going to draw 12 of them. I know those colors look kind of the same, but I think you can tell the difference. And then, guys, because there are 6 oxygens that make up this molecule, we are going to add 6. Now, you could add all of them to one side. You could stagger them, and that's actually what I'm going to do. I'm going to kind of, I'll put one here, and I'll put one over here, here, there, there, and then put my last one right down here. Now, glucose itself is this type of sugar, and it doesn't actually have a super strong bond to it. So what we're going to do to represent the bonds is we're just going to do single lines, just like this. We notice that they do attach in such a way as this. And then those oxygens are also going to be attached just like so. This is a model representation of what I think glucose could look like. Now, when you guys get to the drawing part of this, which I'll show you in just a bit, yours can look a little different. But the only thing I really want you guys to understand is carbon is the strongest of these elements, and it is what has to make up the backbone of this particular molecule. Okay, otherwise the whole thing's just going to fall apart. Okay, all right, the final one, let me find my eraser. There it is. Okay, the final element or the final compound that we have to talk about when it comes to photosynthesis is oxygen. Now, oxygen is simply represented with an O2, okay? O2 means that there's got to be 2 atoms that make up 1 molecule. Now, the great thing about oxygen, guys, we can't actually see the bonds with them. Basically, we would take two atoms and we would just kind of put like a sideways 8, and that's going to be one molecule of oxygen. And because in photosynthesis we got to have 6 of them, you'd have to draw 6 of those. So what am I really getting at here? With the Skittles project, if we had been able to do it, you guys actually would have been building these molecules out of the Skittles and then drawing what they look like on a piece of paper. I can't get the Skittles to you guys. If you want to go buy Skittles and do this, you certainly can. I'm not saying you don't have to, or you don't. If you want to, great. If you don't want to, fine. I'm not going to worry about it. But what I do want to do is I want to make sure you guys understand both photosynthesis and cell respiration. So what I'm going to ask you guys to do for me is to create a visual representation of those two equations. Now, I actually did one, and I'm going to show you mine so that you guys have a good example of something to go off. This is going to be my representation of photosynthesis. What you are going to have to do then is you're going to have to take everything that I do for photosynthesis, flip it, because you are going to have to show me cell respiration as well. So here is what I would have used to represent the Skittles Lab. So the first thing you did is notice is I picked my 3 colors. Okay, I already talked about these, but I did exactly what I just showed you guys to build this. Okay, so I went right through the equation of photosynthesis. I started with carbon dioxide. I had to build 6 of those molecules. To that I added water, which I built 6 of those. And then when we add a little bit of light energy, that's my sun. It's not a great picture, but never claimed to be an artist. We shake those 3 things around, and what we're going to get is we're going to get that sugar, glucose, and the oxygen molecules. This is exactly something that I would like to see you guys build and draw, and then send me a picture so I can grade it. Okay, so this is photosynthesis. You guys are going to have to figure out cellular respiration. Now, again, remember we talked about this before. It's basically a reversal with one exception. Okay, the products become our reactants. The reactants become our products, but this is where we are going to have to make a little bit of a change. So when we talk about cellular respiration, instead of light energy being used to trigger this, we're going to be using ATP energy. So you'll notice that down here, I put down that it's food. What I would suggest is you start by drawing your glucose molecule, draw your oxygen molecules, draw me a picture of your favorite food, whatever it might be, pizza, ice cream, I don't know, candy bar, okay? And then over here, we're going to have our carbon dioxide, and we're going to have our water. Now, make sure that your molecules, even though they're not in the same place as photosynthesis, they should look exactly the same, just in a different order by the time you're done. So, you guys are going to build me some visuals. I need a visual for the process of photosynthesis. I need a visual for the process of cell respiration. Once you guys have sketched those, take a snapshot, email it to me, whatever you need to do, get me those pictures just so that I can see you understand these processes, okay? I wish we'd been able to be together to do the Skittles Lab because it's a really fun thing and I really, really enjoy doing it with you guys, but we just weren't able to do that this year. I hope that this is going to be helpful. If you have questions, please don't hesitate to email me, get a hold of me some way, somehow. Basically what I'm going to do here, guys, for the rest of this week, this is Tuesday. Okay, this is your assignment for Tuesday. It's going to be due by Friday evening. I'm going to give you one more assignment, and then Thursday and Friday are going to be kind of makeup days in science. If you have everything done, you're done. You have nothing else to do. If you still have some work to get done for me, Thursday and Friday are your chance to do that because I got to have grades done by very beginning part of next week, and I would prefer to have them done this weekend. So if you have questions, let me know. Otherwise, go back and look at your work. Good luck. Hopefully this is not going to be too confusing for you guys. Give me a heads up if you need something. If you need some help from me, email me, and I'll see if I can help you out, all right? Hey, hopefully we'll catch you guys a little bit later, okay?